With Java 8 opening up the door to the functional programming world, you can imagine that there'd already be tons of methods which you could use in a functional context. Of course, the question is, how do you do that? Well, the language designers have thought of this too as it happens, and so in Java 8 method references have been introduced, which lets us do just this very thing. Method references are a new feature in Java 8, and they allow us to refer to an existing method in a Lambda expression context. Let's have a quick recap of lambdas and functional interfaces in Java 8, so we can put method references in context. First up, here's a Lambda expression. This will take a string and print it to the console when it's invoked. Nothing fancy, it's just a system out print line, which takes the message to print. Everything needs a type in Java, and so we have seen that we can assign this Lambda expression to a functional interface like this. So what we're actually doing here is packaging up some implementation, in this case a system out print line statement, which will print some message, and assigning it to a functional interface. We could assign it to any functional interface which matched the implied method signature of the Lambda. But we'll use one of the standard functional interfaces here, which means a function that takes a value as input but returns no output. This is a consumer. It consumes the input parameter. Through this, we have captured the function, but not yet invoked it. So we can then do that quite easily like this. We're now applying the function, the consumer, by passing it what it needs, its input parameter, as required by the consumer functional interface. And when running this, the message is printed. Now, where you have a Lambda expression which just calls an existing method, you can use a method reference instead. So to take the two lines of code we just wrote together, which looks like this when we see it side by side, these could be replaced by this. So as you can see, we've replaced this Lambda expression with this method reference. This is a reference to the static method printline defined on the system.out object. Now, this should feel fairly intuitive once you get your head around Lambda expressions and functional interfaces. All we've done is swapped out the Lambda for a reference to the one and only method call it makes. At this stage, now you've seen how easy it is, let's dig a little deeper and look at the different types of method references we have available to us. They all follow the same general syntax with the double colon separating the type or object and the method, but it's worth going over the 4 types of method references we have. Now, a quick word of warning. If you read any documentation on Oracle's website about method references, you'll see that they use some pretty confusing and wordy definitions. So I'll give these definitions here now in the bullet points we'll go through, but as we explain each one, I'm going to give a clearer name for each so you can more readily hold it in your memory and understand what it is. So don't panic, these are going to sound hideously complicated, but it's not too bad once we see what each one is, and when we look at the examples, it should become pretty clear that these types of method reference are the obvious ones we should have anyway. So, deep breath now, hang in there. The types of method references are as follows. A reference to a static method, a reference to an instance method on a particular object, a reference to an instance method on any object, and a reference to a constructor. There's a lot here, so let's see examples one by one. First off, let's look at static method references. For this, let's consider the static method parseInt on the class integer. This can be represented as a method reference like this. Note, since the parseInt method takes a string and returns an int, we can use the function of string and integer type to reference it, so it can be assigned and stored like this. Also, as a brief side point, notice that the parseInt method actually returns a primitive int type, but we're allowed to use the function which references the integer wrapper type, since the result will be autoboxed for us from the primitive int into the integer wrapper type reference. It's good to know that the autoboxing feature still plays nicely with all this functional stuff which has been added to the platform. Anyway, once we have the method reference, we can invoke it like this. Here we're passing in the string literal 35 and getting back the actual value as we'd expect. So those are static method references, which we use when we refer to a static method on a class and reuse it in a functional context. Next we have instance method references, and there are 2 types of these, bound and unbound, as we'll see. Now, whereas a static method reference refers to a static method on a class, these types of method references, these so-called instance method references, refer to an instance method on a class. Since we have a reference to an instance method, it ultimately needs to be invoked against some actual instance. Now we can choose whether we create the method reference to refer to an actual instance when the method reference is defined. This is the bounded type, or we can choose whether to defer that binding till later and not specify the instance. This is the unbounded type. Again, some examples should make this clear. Take the string class. This defines a method toUpperCase, which operates on a string instance. It's an instance method. If we have an existing string object we'd want to invoke the method reference against, we could supply it like this. Notice that we don't use the string class name when we declare the method reference, but refer to an actual variable which holds a string instance. This is why it's lowercase s : toUpperCase. Now, since we're invoking a method reference against a specific instance, this method reference is a supplier, which returns a string, so it can be assigned and stored like this. Then at some stage, it can be actually invoked to get the result like this, returning the capitalized version of the string. At this point, you might be thinking, I don't get it. Why is the toUpperCase method a supplier? It's blatantly a function which takes a string and returns the uppercase version, which is also a string, so surely it should be function of string. So yes, you would be right for an instance method reference of the unbounded type, where we don't supply the instance when declaring the method reference. In that case, yes, it takes a string and returns a string, and so is a function of string. But not for an instance method reference of the bounded type, since in this case, we're binding the actual instance the method reference will be invoked with when we declare the method reference itself. And so it doesn't take an input, it just returns the output. And anything that just returns output is a supplier. So in this case, it is a supplier of string. So, just to repeat that, it's pretty important. With the unbound instance method reference, there's no context associated with the method reference, no object. Just look at it. It's string with a capital S : toUpperCase. There's nothing about an actual instance in this definition, and so when you invoke it, you need the string to invoke it against, and then it returns the uppercase version. So string in, string out, that's a function then, so a function of string. But with the bound instance method reference, we do have context stored against it. This is provided by the instance it's been invoked against, and so this is like having a function that's already been filled in with its input. So because of this, the toUpperCase method reference is no longer a function now. It's already had its input set when we created the method reference. As you can see, we created the method reference by specifying the instance it is to be invoked against, and so it just returns a value. And for that reason, it's a supplier, which is the functional interface which just returns a value and doesn't take any input. By the way, when you partially fill in the arguments for a function, technically create another function by binding one or more of its input parameters, like we've done here, the term for this is currying the function. It's fairly advanced though, and we don't want to get sidetracked, but I thought I'd mention it in case you ever hear this term in future. Now you'll know what it means. Anyway, let's crack on and have a bit of a breather now with something that's finally easy to understand: constructor method references. So, lastly then, we have constructor method references, which, as I said, come as a pleasant surprise since they're easy to understand and use. This is just a method reference which expresses a call to a constructor, like when you invoke the new operator to create a new object of a given class type. For example, if we consider the constructor to create a linked list of strings, its corresponding method reference is this. We can assign and store it like this. It's a constructor, so it's going to return as a value, namely the instance of the list being created, so we can type it to a supplier of list. And the specific list it returns is a list of string. Finally, we can invoke it to get the list like this. Notice that the functional interface for constructor method references is a supplier, and this takes no arguments and just returns something. So this means that you can only call no argument constructors. In other words, the basic default constructors you'd get in Java, which take no arguments when constructing the objects. It's a limitation, yes, but there it is. Well, that was quite a lot of ground we covered in this module. As you can see, method references aren't so bad once you get the hang of them. You just have to consider what the target type can be, and this is derived from its context. Once you have them, you can use them wherever Lambda expressions can be used. And in particular, you'll see them used a lot in pipelines, where stream-based programming comes into play, and with the optionals API too. Now that you can spot them, they should be easier to work with, and as you've seen, add an elegant way in Java 8 of referencing already existing methods in a functional context.